Hey guys, all right, you've made it this far. We're on the last lesson for today. So lesson 97 is going to be talking about similar triangles. So we're kind of going to break down the properties of similar triangles, and then we're going to look at some applications. And it's going to end, spoiler alert, with a challenge that could get you some bonus points on your next test. So stay tuned to the end. All right, so if we look at these two triangles that I've drawn here, we can see, first I want to talk about the what's the word I'm looking for? The signage or the whatever, signage, I guess, that kind of indicates to us the congruency of the angles. So if you notice, these two angles right here both have one little tick mark through them, and these two angles up here both have two little tick marks through them, okay? The ones with one tick mark, that tells me that those two angles are congruent to each other. So if this one's 30, this one's 30. If this one's 60, this one's 60, okay? Those are just examples, but the point is they are congruent to each other because they are marked the same way, okay? Now we can also determine, based on what we know about triangles, we know, this is where I would say, how much do all the angles in a triangle equal? And you would say 180, and I'll be like, good job, you're right. Okay, so the sum of all the angles in the triangle is always gonna be 180. So if I know the total is always 180, then I could add up these two angles and subtract from 180 to get this third angle. So if these angles are the same, then that means when I add them up and subtract from 180, it's also gonna give me the same thing. So what that tells me is that this third angle is always going to be equal to each other too, okay? So that leads me to the first statement that we can make about similar triangles. In similar triangles, the corresponding angles are always congruent. So corresponding angles congruent. Okay, so in this case, the corresponding angles are angle A and angle X, angle B and angle Y, and then angle C and angle Z. Those are all corresponding angles, meaning they are all congruent to each other. The sides, however, if you'll notice just by looking at them, we can tell that this side, AB, which corresponds to this side, XY, they're definitely not the same length. So while the angle measures are congruent and they are the same, the side measurements are not going to be congruent in similar figures. However, they do have a relationship. So while the corresponding angles are congruent, we know that the corresponding sides are actually proportional, which should sound familiar because we have learned a lot about proportions. So what that really means is that I can set up proportions or set up ratios equivalent to each other to form proportions for the sides. So here my corresponding sides would be AB and XY, BC and YZ, and then CA and ZX. Sorry, my board's a little messy down there. Hope you can still see that. Oh, and there's a glare. Let's see if I can. Oh, there we go. Better. Okay, so those are going to be my corresponding sides, and they are, again, proportional, not congruent. So like if this one's 4, this one is not 4. It's something else. But its ratio, its proportion is going to be directly, or its measurements are going to be directly proportional to 2 of the other sides, or any of the other sides, really. So we'll look at what that looks like in a different example. So let me set that up for us. So if we've got this triangle and this triangle, those kind of look similar, right? Yeah, okay. And we've got measurements of 8, 6, and 10, and measurements of 4, 3, and 5. And we know that these are both right angles, and we know that these are congruent and these are congruent. Well, that tells us that these are similar triangles. So if they're similar triangles, then we know we can create equivalent ratios for the corresponding sides. That was a lot of big words. Let me see if I can break that down for you. So we know that this side is like on the, I erased that. This side is like connected to the right angle, right? And it's the one that stands up. So these two sides correspond to each other. So I can make a ratio out of them. 6 and 3 correspond. So I'm going to set it up as a ratio 6/3. Then I can look at the next pair of corresponding sides. These two sides correspond to each other. So just like I did 6/3, I can set up a ratio of 8/4. And then we've got these two sides that correspond to each other. So just like I did 6/3 and 8/4, I can set up 10/5. So all of those, any of those could be set up as a group of two proportion, or a group of two ratios to make a proportion if we were needing to find a missing piece, which is actually what we're going to look at next. And if you notice, these are all directly relational to each other. If we were to cross multiply, 8 times 3 is 24, 6 times 4 is 24, 10 times 4 is 40, 8 times 5 is 40. That tells us that they are, in fact, proportional by cross multiplying and getting the same result. Okay, so let's look at one where we actually have to find a missing side based on the fact that we know they're proportional. Y'all bear with my drawings here. I know y'all do it in class every week anyway, but you know they're not perfect. I do my best. We'll try and make them look as proportional as possible. That's about as close as it's gonna get. Okay, so we've got 5, 3, and 6 on this one, and then we've got A and 10 on this one. So now we're told that this angle is congruent to this angle is congruent to this angle. It's important to pay attention to the angle congruencies because that kind of helps us see that these shapes are in the same orientation. That means this is the top of this one and this is also the top of this one, okay? So you want to pay attention to the angles. They don't really mean anything when we're trying to find a side that's missing with proportional sides, but they do help us connect the correct sides to each other, to the one that they correspond to. So you do have to take note of that. Okay, so this is the one we're missing, and it corresponds to the 3. And then if you'll notice, the only other one we're given over here is the 10. And so we know that it corresponds to the 6. So we could set up a ratio of the 6 to its corresponding side, 10. And then the 3, we always want to start back on this same triangle over here, to its corresponding side, A, which is the unknown. So now we're trying to solve for A, okay? We could cross multiply, or you can look at how it changes from here to here. So to get from 6 to 3, we just divide by 2. Well, we could just do the same thing here. 10 divided by 2 is 5. So that means A has to be 5. There you go. All right, so let's look at indirect measure. So indirect measure is a little bit more application of this concept. So like, how does this apply to everyday life? Everybody's favorite question with math. So this is actually pretty applicable, and you're going to see that in the challenge that I give you at the end that you can get bonus points for. So here it gives an example, and I'll kind of read a little bit of it to you, but I'll kind of also just try to sum it up because I don't like to just sit here and read to you. You have the book in front of you. You can read yourself. We're on page 666. Ooh, mark of the devil. Okay, so we've got Sarah looking up at a tree and saying, I wonder how tall that tree is. And then Beth looking down and saying, it's about 25 feet tall. So how could Beth tell if Sarah was looking at a tree? So here's Sarah. She's got curly hair. Sarah's looking up at the tree and she says, I wonder how tall that is. And Beth looks down and she says it's about 25 feet tall. Well, what is down that could help her identify or estimate how tall a tree is? The shadow. So she's looking at, okay, well, I can't really properly estimate how tall that tree is, but I can look at the tree's shadow in relationship to my own shadow. So then if you look at what that forms, so we've got the height of the tree and the shadow of the tree, it makes a triangle. So because the sun is hitting both her and the tree from the same angle, that means that the triangle formed from the height of the tree and the shadow is going to be similar to the triangle formed by her height and her shadow. So you can actually use those shadows to estimate how tall something else is if you can reasonably determine how long your shadow is, how long the tree's shadow is, and how tall you are. Because it's a whole lot harder to climb up inside of a tree and figure out how tall it actually is. So this is a good alternative method to finding out the height of a tree. So let's see. She says, okay, I know my own height is 5 feet. So she's 5 feet tall. So that means that this part right here is 5 feet. Okay. And then she estimates that her shadow is about 6 feet. Then she estimates that the length of the shadow of the tree is about 30 feet. So really, you don't have to estimate this though. You could measure it out. You could use a measuring tape. To measure your own shadow, you're probably gonna need a friend to help you because you can't like bend down and do it because your shadow will get messed up. So you'll have to stand up, get a friend or brother or sister or somebody to help you measure your own shadow, okay? You can measure the shadow of the tree a little bit easier, but use a tape measure or something. You can measure your own shadow in this instant. And so about 6 feet here, about 30 feet here. So then really all we're looking for is the height of the tree. So we can create a proportion just like we did before in the example with the corresponding sides. So we know that the X side corresponds to the 5, the height to the height. And we know that the length of the shadow, 30, corresponds to the length of her shadow, 6. So now if we want to solve for X, what do? And you would say cross multiply. And I would say, good job. So we cross multiply. 30 times 5 is 150. 6 times X is 6X. So we want to get X by itself. We divide by 6, divide by 6. Okay, and so that is going to give us 25, right? 30 times 5, yeah, 25 feet. So the tree then is about 25 feet tall. So that is what I want you to do for your challenge. So I want you to go outside and find an object. It doesn't have to be a tree. It can be a pole. It can be a house. It can be anything, but something where you can clearly see the shadow, okay? So I want you to take a picture of the object, and I want you to draw out a picture of your height and your shadow along with the height of whatever it is that you're measuring, tree, house, whatever, and its shadow. And I want you to actually measure. So get outside with a tape measure and measure your shadow, which again, like I said, you're gonna need a friend to help you with that, okay? You hold it on one end or like put it under your foot and stand up straight, and then let your friend measure how long your shadow is, okay? And then at the same time, you can't do this, you can't measure yourself at 2 o'clock and then measure the tree at 5 o'clock, okay? Because the sun moves. Remember, the important thing is like the sun is hitting at the same angle. So you got to do it at the same time. So you measure your own shadow, then you measure the shadow of whatever else it is you're measuring, like a tree or something else, okay? So measure those things and then set up a proportion just like we did to try and identify the height of the other object, okay? It may not be exact because sometimes these things are a little messy, but I want you to do the best you can to try and find it. Also, your shadow is going to be a little bit longer, making this a little bit easier. Like if you do it kind of earlier in the morning or like in the evening, not too late in the evening, but a little bit later, because right around noon, the sun is like straight up. So shadows aren't that long. So it makes it harder. So try and do it in the morning or like later in the afternoon. Take a picture of the object and sketch it all out with the proper measurements that you actually found. Okay. And then send that to me attached to your test. So like when you send in your test to me, send that in too next week, and you will get 10 bonus points on your test for that. So there's your challenge. Have fun and get outside. It's a good way to get outside and do something. All right, this is it for this week of math. You guys have done a great job. I can't wait to see you again on our Zoom meeting next week. So happy homework.